Alright, the speed of a runner was detected at half-second intervals for the first 3 seconds and recorded in a given chart. Approximate the distance she traveled during the first 3 seconds by using midpoints of 3 subintervals. Alright, so if I try to break this up into 3 parts, looks like this would be a part. There would be my second interval. And then there would be my third interval. So from 0 to 1 is interval 1, 1 to 2 would be interval 2, and 2 to 3 would be interval 3. Since this says midpoints, and we've got 3 subdivisions, we should be adding the area of 3 different things. So I make those 3 different blanks. And so to estimate this, it's like we're trying to find the area under a curve. So if you had unlimited time, I guess you could make a quick little graph. You could plot these points. You could kind of connect them, roughly connect them, and you'd have a visual of what you're looking for. But when I look at this one, whether it's midpoint Riemann sums, left Riemann sums, or right Riemann sums, it's all rectangles, so length times width. So the width of this guy would be 1. 0 to 1 is 1. Looks like the width of this guy would be 1, and the width of this guy would be 1. But what's going to change is the length of each of those rectangles. Since it's a midpoint, you should take the value in the middle. So in the middle of the first interval would be 6.2. And the middle of interval 1 to 2 would be 14.9. And in the middle of interval 2 to 3 would be 19.4. And we use our calculator there. I guess we didn't have to use our calculator on that one, but 40.5 and since this is feet per second and this is second, distance would be feet still. .5 feet. Alright, you okay with that?
Yep.
Okay. Anybody else that was going to ask this one want to ask while it's still up? Another example of a really good question where arithmetic is, and the process is very straightforward, but it's more or less just testing you if you know what to do with all of that mess of numbers. So.